Hello everyone, welcome back to our channel. This is Dr. Lakshmi Tara. So here we are going to see about the fiber optics and the optoelectronics. Okay, so what we have seen in the last session, we have seen about the propagation of light in the optical fiber, that is the working mechanism, working phenomenon we have seen, that is about Snell's law, total internal reflection, what are the types of rays. So these are the things we have seen in the last session. So today we are going to see about the very important parameter in the optical fiber communication. So very important parameter is nothing but the wavelength or the frequencies that are very much important in the optical fiber communications. So based on that only we can calculate the number of modes that is guided by the optical fibers. If the wavelength is shorter, it can guide the more number of modes. Vice versa, for the longer wavelength, only a single modes has been guided. Okay, so at minimum wavelength, okay, the minimum wavelength that is known as the cutoff wavelength. Okay, the minimum wavelength that supports the single mode is known as the cutoff wavelength. So above that cutoff wavelength, only that linear polarized modes, that is has been propagated. Okay, below that cutoff wavelength, the higher modes has been propagated. So once you understand the cutoff wavelength, then the important thing is the cutoff frequencies. Okay, each and every mode has the corresponding frequencies. So below that the mode cannot be propagated. So a particular frequency, okay, for a mode there should be the particular frequencies, that is called the cutoff frequencies. Okay, so below that frequencies the mode cannot be propagated. Okay, so for example, for a mode to propagate, okay, for any kind of mode to propagate inside the fiber, okay, the V number, that is the normalized frequencies of the fiber, should be greater than the normalized frequency to the cutoff frequencies of the mode. Okay, so what are the modes that is going to propagate? Okay, that V number should be lesser than the V number of the fiber. Okay, so the normalized frequencies V number is given by V is equal to 2 pi a by lambda square root of n1 square minus n2 square. So what is A? So A is nothing but the radius of the core. So it's not the diameter of the core, it's the radius of the core, and the lambda is the for the wavelength. Okay, so frequencies we know that. So frequency has been calculated by 2 pi a by lambda, which is multiplied by the numerical aperture. We know the formula for the numerical aperture. So if the both core refractive index and cladding refractive index as given as the parameter, so it is easy to calculate the numerical aperture using the formula square root of n1 square minus n2 square. If not, only core refractive index is given and this delta value is given, that is the index difference value is given. So we can go for the formula is n1 into square root of 2 delta for calculating the numerical aperture. Okay, so how the number of modes has been supported by the fiber. So we know that V is equal to 2 pi a by lambda square root of n1 square minus n2 square. So number of modes in a kind of fibers which is differentiated by the refractive index difference. Okay, so always the V number should be lesser than 2.405 for the single mode fiber, and for the multi-mode fiber the V number should be greater than 2.405. Okay, in order to calculate the number of modes for the step index fiber, there should be the formula n is equal to V square by 2. Okay, so V is the normalized frequencies. For the graded index fiber, n is equal to V square by 4. Okay, in order to understand, we can go for the exercise problems. Okay, so what is given here? So calculate the normalized frequencies, that is the V number, for given core radius of 25 micrometers. So here it is given as a so it is a micrometer, and the index of core is 1.48, the delta value is 0.01, lambda is equal to 1320 nanometer. So calculate the number of modes supported in the fiber. So here we need to calculate both the normalized frequencies. So once we calculated a normalized frequencies, we can calculate the number of modes. Okay, so they have given the core radius of 25 into 10 power minus 6. The micrometer is 10 power minus 6 meter. So n value they have given 1.48 and the delta value 0.01. So if we know the value of n1 into delta value, we can easily calculate the value of numerical aperture, that is n1 into square root of 2 delta. If you substitute the value, we can get the value of 0.209. Okay, so other parameters they have already given. The a value they have directly given, lambda value given, and once we find the value of Na, we can directly find the value of normalized frequencies. Okay, so how we can calculate the number of modes? For the step index fiber, it should be what? V squared by 2. For the graded index fiber, it should be V squared by 4. So easily we can find the number of modes supported in the fiber. Okay. And the next problem, so what is given in the next problem? Consider a fiber that has a core refractive index of 1.480 and a cladding refractive index of 1.476 and a core radius of 4.4 micrometer. Show that the wavelength at which this fiber becomes single mode fiber in lambda c is equal to 1250 nanometers. So what they have asked, so they need to they asked to show that wavelength is a fiber is the single mode fiber. Okay, so we know the how to identify the single mode fiber. So we know that V value should be lesser than 2.405 for the single mode fiber and greater for the multimode fiber. Okay, so once we find the value of V, we can justify the answers. Okay, so directly they have given the value of a core refractive index and the cladding refractive index. With that we can directly go for the finding the numerical aperture, that is Na equal to square root of n1 square minus n2 square, and we know the formula of 2 pi a lambda and the Na. Okay, they have given the lambda value of 1250 nanometer. So nanometer is nothing but 10 power minus 9, and they have directly given the radius value of 4.4 micrometer. So 4.4 into 10 power minus 6. So our obtained answer should be 1.398. That should be lesser than 2.405, since the fiber becomes the single mode fiber. Okay. Next problem. So what is given in the next problem? Consider a multimode step index fiber with a 62.5 micrometer core diameter. So they have mentioned the diameter here, but the A stands for the core radius. Okay, and core cladding index difference of 1.5 percentage. Here the delta value as given in the form of percentage. Okay, if the core refractive index is 1.48, estimate the normalized frequency, that is the V number of the fiber, and the total number of modes supported in the fiber at a wavelength of 850 nanometer. Okay, only wavelength as given directly, that is 850 nanometer, but the radius they have given in the term of diameters. So we need to convert into radius, that is divided by 2. 62.5 micrometer divided by 2, then we can get the value of A. Okay, so here it is given. And for numerical aperture, so for numerical aperture we know the formula. I am write n1 into square root of delta. So delta is given in the terms of 1.5 percentage. So 1.5 divided by 100, so it will become 0.015. Okay, so with that we can easily find the value of numerical aperture. Okay, and the radius is 62.5 divided by 2, and the given numerical aperture value, with that we can find the value of V, that is normalized frequency as 59.2. Okay, I hope you have understand about the cutoff wavelength and frequencies, normalized frequencies, that is the V number, and also you have understand the value of V number for the single mode fiber and the multimode fiber, how to justify whether it is a single mode fiber and the multimode fibers. I hope you understand. Thank you so much.